Chapter 10, Mechanical Waves and Sound Wave. 10.3 Sound Intensity. At the end of this chapter, students should be able to define and sound intensity, discuss the dependence of intensity on amplitude and distance from a point source by using graphical illustrations. Sound intensity. Sound wave is a mechanical and longitudinal waves. It cannot show the effect of polarization. It travels inside of compression and rarefaction series of the medium. The distance between the two centers of the compression represents the wavelength. The type of sound wave is progressive sound wave and stationary sound wave. The speed of sound is not depend on the pressure and density of the air, but its value depend on the temperature of the air. Intensity of sound wave. Definition. It is the rate at which the energy is transferred per unit area of the medium. The formula is I equals to E over T over A equals to P over A, and I equals to P over 4 pi R squared. The unit is watt per square meter. The physical quantity is it is a scalar quantity. The diagram shows example of intensity of sound wave. You need to take note that the power carried by a sound wave spreads out after leaving a source. The greater the distance from the source, the larger the area over which a given amount of sound energy is spread, and thus the lower its intensity. Amplitude of sound intensity is directly proportional to I, and intensity of sound is directly proportional to 1 over R squared or inversely proportional to R squared. Two points at distance R1 and R2 from the source, power P is constant, then I1 equals to P over 4 pi R squared and I2 equals to P over 4 pi R2 squared. So we will get I2 over I1 equals to R1 squared over R2 squared. Therefore, A is directly proportional to 1 over R. Graphs in figure 10.6 show the variation of sound intensity. The end. Next chapter, chapter 11, Deformation of Solids.